Hello, so I'm going to record this video going over relations and functions notes. This is going to be the very first unit, very first lesson of Unit 1. So you could be watching this for a number of reasons, whether you're stuck at home because of a quarantine, or because you missed class and you want to get caught up, or because maybe you're having trouble on the practice the next day and you want to go back and look at the video. But regardless, I'm going to kind of walk through these notes, so skip ahead, as you will. So we're going to first start off with, what is a mathematical relationship, okay? So a mathematical relationship is a connection between two quantities. So quantity is just a number, all right? So there's some connection there, right? And specifically, we're going to talk about a very important type of relationship, right? It's a subset of all mathematical relationships, and that's a function, all right? And we spend a lot of time in math talking about functions. So what is a function? Okay, well, a function is a relationship, right? A mathematical relationship where each input has exactly one output, all right? And that's very important. Not more, not less. So if an input doesn't have an output, not a function. If one input can have two outputs, not a function, okay? So there are plenty of relationships that aren't functions, but all functions are relationships. So a relation is a function sometimes, all right? And we'll be showing you today some relations that are not functions. But a function is a relation always, okay? So it's a type of connection between two quantities with a specific caveat that each input has exactly one output. So now that we actually, have, relations and functions, now we're going to start talking about domain and range, all right? So the domain of a function is the set of all inputs. Another way to say that would be x values, all right? Because we've talked about how the x value of your function is your input. And then the range of a function is the set of all outputs, or y values. Okay? So domain is inputs, range is outputs. One way that you can remember that, all right, the last two letters of domain is in, all right, input. I've heard, many other things, but that's just one way to remember it. So we're going to look at some examples here. Most of this, all right, set of notes is pretty much all going to be domain and range from here on out. Domain and range is really important, all right? The Algebra 3 teachers specifically said do a lot of domain and range, okay? So we're going to help prepare you for next year. So domain and range are typically written one of two ways, all right? The first way is as a set using these little curly brackets, all right? In mathematics, the curly bracket denotes a set, all right? So you'd have the curly brackets, and then you have a bunch of stuff inside of it. Those would be all the things that are inside the set. So do not forget these, all right? My students last year did that all the time. It drove me crazy. So example 1, all right? We have this function here, okay? And we want to list the domain. All right, so if you remember, the domain are all the x values. So every number that I just underlined, those are the domains, or those are the inputs. All right, so our domain is going to be 4, 1, -3, and -2. All right, and that's it. You don't have to put them in a specific order or anything like that. Just list out all the inputs. Range then is the set of all the outputs. So the outputs would be the number that comes second in the coordinate. So we've got 6, -2, 5, and -5. Oops, see, I almost messed up, put a parentheses, all right? Curly brackets is what we want. So range are those 4 numbers. Now, is this a function, okay? So the way to tell if it's a function or not, right? So more, I guess you would look at the way to tell it's not a function is if any of your inputs can go to multiple outputs, which here is not the case, all right? We have 4, 1, -3, and -2. So none of those inputs repeat, right? So all of the inputs only have one output. So is this a function? Yes, all right. Example 2. So another way that this could look is you could have this thing, this chart, all right? But it works the exact same way. So if you look at how it's labeled, X, Y, right? So your inputs are on the left, your outputs are on the right. So we're going to go over this one, all right? So our domain is going to be just all the numbers that are in the X bubble of this chart. So we've got -1, we've got 0, we've got 1, 2, and 8. All right. Then we have range. So the range then would be all the Y values. So we have -3, -2, 2, and 3. And is this a function? So some people might say no, right? They might be tempted to say it's not a function because here, all right, -1 goes to 2 as well as 0 also goes to 2. But remember, it doesn't say that each output has to only have one input, okay? You can have as many inputs going to the same output as you want, as long as each input has exactly one output, and that's the case here, right? -1 has one line, 0 has one line, 1 has one line, 2 has one line, and 8 has one line coming out of it. So this actually also is a function. Example 3. All right, example 3, we could look at a table. You know, it's all different ways of representing the same thing. Again, the domain is all the X values, right? That's the left side of our table. So we're going to put our curly brackets, and we're just going to start listing out the X values. So we've got -2, we've got 0, we've got 4, we've got 5. All right. So those are all the X values. For the range, we have all our Y values. We're going to do the same thing. We've got 14, we've got 6, we've got -10 and -14. And again, is this a function? Yes, all right. None of our inputs repeat, all right? Each input is only going to one output, so therefore, yes, this is a function. All right, example 4, okay? This is another way this could look, all right? We could just have a bunch of points, right? And this one is a little bit tricky because you don't necessarily know what the numbers are right off the bat. You kind of have to go to each point and look at the numbers. So if we want to list out our domain, okay, remember that's the set of all inputs or X values. And we know in a graph, hopefully, that this is our x-axis. So we want to get all the x coordinates of our points. All right, so we're going to start at C. All right, so C goes to -6, so that's our first x value. B goes to -3. E goes to 0. D also has an x value of 0, so we don't need to write 0 twice. All right, we've already written it once. F, that's x value is 4. A's x value is 5. And then G's x value, it looks like this is actually in between. So that looks like it's about 6.5. Interesting. So those are all the x values that we have. Next, our range is going to be all our y values, okay? So we're going to do the same thing that we did before. We can look here. So this F point has a range of -5. C has a range of -4. D is at -3. then we come up here. So E is at 0 and G is at 0. So again, I'm just going to put 0 once. B goes to 1. And A goes to 3. So I'm just looking at what is its coordinate, all right? And that's telling me the domain and range. Now, the last question here, is this a function? The answer for this one is actually no. Okay, this is not a function. Why is it not a function? It's not a function because of right here, okay? If we look at the input 0, all right, E has the coordinates 0, 0, and D has the coordinates 0, -3. So the input of 0 actually has two outputs here, all right? So that's why this function, or I guess it's not a function, this relation, all right, is not a function, okay? Because 0 has two outputs. So pay attention to that, all right? So this is the first way that domain and range is written, all right? You use the curly brackets and you just list out the numbers. The second way to express domain and range is using an interval. So an interval is done when a function is continuous, all right? If you don't know what continuous means, all right, continuous means it's all the points are connected and your line is unbroken, okay? So why don't we want to list it out as a set here? Well, the number of x values in this graph is infinite, okay? It would literally be impossible for you to list out all the x values, right? This x value is 0 right here, right? This x value is 1, but isn't there a point right here with an x value of 0.5? And isn't there a point right here with an x value of 0.25? And isn't there an x value right here with a with a value of 0.75? And you could go on forever. 1.5, you know, that's 2.5, you know, 2.25, 2.3, 2.31, it's forever. All right, there's an infinite amount of like little decimals and fractions where points exist on this line because this line is continuous. So you cannot list out the curly brackets and numbers if you have a line that is connected like this, okay? You can't do it. What you have to do is write it as an interval, okay? And so when we say an interval, it's going to be written in interval notation, just like when we did solving inequalities, okay? So domain and range are your inputs. All right, this is very important to pay attention here. Your x-axis is your domain, we know that, all right, and that's going left to right. So when you're looking at domain, you want to look at the far left point on the graph, and you want to look at the far right point on the graph. What do we see? In both of these cases, all right, we see arrows. And if you remember, all right, when we talked about interval notation, arrows mean infinity. So on the left side of our graph, right, even though it looks like it's going up, it's also slightly going to the left, all right? And so if you kept this going forever and ever and ever and ever and ever, it's going all the way to the left to negative infinity. Same on the right, it looks like it's going up, but it's moving slightly to the right. So it's also going to positive infinity. So the domain here is just negative infinity to positive infinity. All right. For range, all right, for range, you are looking at the y-axis. And for range, you only care about, for range, you only care about up and down, right? The y values are up and down. So we want to look at the bottommost part of the graph, which is right here, and then the topmost part of the graph, which is up here. So range, you write from bottom to top, because you always write smallest value first. So the range is actually -4, all right? There's no arrow down there. And just like in interval notation, we're gonna write this with a bracket because it's actually touching -4, okay? So we are including -4 in our interval. At the top, we have two arrows, both going up. So arrows mean infinity. So the range is actually -4 to infinity. And how do we tell if this is a function? Well, you might have, remember this thing, it's called the vertical line test. All right, if you can draw a line and it touches the function twice, it's not a function. All right, if it touches the graph twice, right? Why is that the indicator? Well, come look here, right? We talked about how if we draw a vertical line here, we're touching E and D. That's because that input of 0 had 2 outputs. So if you can ever draw a line and touch 2 points, then that input at that line has 2 different outputs. So this is a function, right? There's nowhere that we can draw that line. All right, example 6, we're almost done, all right? Example 6, we have a circle, all right? And so we want to do the same thing that we did before, all right? We want to do our domain and range. So remember, domain is left to right. So for domain, we're looking at the farthest left point on the graph and the farthest right point on the graph. So we need to count here, right? This is our origin, that's 0, 0. So we've got -1, -2, all right? So again, we're going to use a bracket because we actually are touching -2, so we're going to include it. On the right side, we have 1, 2, 3, 4, 5, 6, 7, 8, all right? So our furthest most point on the right is at 8. So our domain for this circle is -2 to 8. Then for range, we're going bottom to top, all right? So we're going to look at the very bottom of the graph and the very top of the graph. All right, and so we can count again. This is -1, -2, -3, -4, -5, -6. And then it's going up 1, 2, 3, 4. It's going up by 4. All right, and again, we're using brackets because we're actually touching. So most of the time when you have a number, you're going to use a bracket, and then you're just going to use the parentheses for infinity because you can never reach infinity. So is this a function? Well, it's pretty easy to tell that no, this is not a function, all right? You can draw a line pretty much anywhere on this circle, and you're always going to be touching it in 2 different spots. So no, a circle is not a function, but it's still a relation, right? So you got to keep that in mind. So that's all we're going to do today. There is a back here, but this is only for the people in class. So domain and range, all right, very important. If you have any questions on domain and range, make sure to let me know, all right? Your practice will be due on Friday. I guess it depends on the group. Anyway, just go ahead and get the practice done, all right? The day after you were assigned this note, just look on Canvas. So anyway, if you have questions, let me know, and have a